This is the foldable for section 9.2. We're going to go ahead and cut it in the middle. I want you to line it up first with the one that says solving quadratic equations. And then right underneath it, you need to put the number 1. You can line it up at the dotted line. You're going to fold it back. And you're going to have numbers 1, 2, and 3 in order. Okay, so what we're looking at is graphing quadratics. We have talked about this before. What you're going to do is put it in your calculator in the y equals. Let me give you one example. And let me zoom out just a little bit so you can see all the calculator. So you would put x is right next to the alpha. Squared is right here next to that comma or diagonal to the 7. Minus, please put minus and not a negative sign, otherwise it won't read it correctly. 8x plus 15. And what we've been doing is hitting second graph to go to the table. Remember, you can always scroll up and down. What you're looking for is this point right here, which is called the vertex. The reason that it's the vertex is because it's symmetrical on both sides. That means if we were to fold the calculator over, we'd have the same thing on both sides. We have 0, 3, 8, and then on the other side, 0, 3, 8. We plot those points, and then we get the information we need. Today, we're adding just a little bit more to what we've been doing. We still need to graph them, but from the graph, there is a possibility that it has no solutions. Yesterday's video reminded you that you could call them roots, solutions, zeros, or x-intercept. They all mean the same thing. All 4 of these names mean the exact same thing. So we're looking for x-intercept. Means that there is no or 0 times that the parabola crosses the x-axis. So look over here. There's no x-intercepts. It does not cross the x-axis. That means that there is no solution. I'm going to keep repeating myself just to make sure that everybody's okay. Saying no solution also means that there's no roots. Saying that there's no solution means the same thing as saying there's no zeros. No x-intercepts. These words are interchangeable. You have to be okay with that. Okay, so the parabola could be facing up and not touch the x-axis, or it could be facing down and still have no x-intercepts. Remember, no x-intercepts is the same thing as saying no roots. No zeros, no x-intercepts. These words are interchangeable. Okay, then why are they called roots? The reason that they're called roots is we don't know yet, but there's a formula with the square root sign on it. The reason they're called zeros is because the y value will be 0. They're called x-intercepts because it will touch the x-axis, and solutions because we can actually solve some of these problems. Let me show you over here. On the next one, we have 1 root 0 means that there is 1 time that the parabola crosses the x-axis. On last time's video, I also made a little sad face because I didn't want to go over factoring with you, but I'm going to remind you today. Let's assume that you have the function f of x is equal to x squared plus 4x plus 4. And I'm going to factor. This is one way to solve for the solutions to this problem because you're actually solving an equation. So this would be x squared, this would be 4, and when you add them together, it would be 4x. Well, it would be 2x and 2x because 2 times 2 makes 4, and 2 plus 2 make 4. That means this is x and this is x, making our factors x plus 2, x plus 2. And remember what we've done before is set it equal to 0, and that's why they're called zeros. We still have to solve it, that's why they're called solutions. So we have x plus 2 is equal to 0. Subtract 2 from both sides, x is equal to negative 2. So this is one way that we have solved quadratics. Well, if we do the other one, it's going to be the same thing, and that's how we know it has one solution. Let's take a look at the graphs. On the graphs, what you're looking for is where it touches the x-axis, and that's why it's called an x-intercept. I don't like this notation, so I'm going to mark it out. That point where it touches the x-axis is negative 2, 0. So that's the x-intercept. But don't forget, it still means that there's negative 2 is the solution. Negative 2 is the root. Negative 2, 0 is the 0. Okay, and then right here, it touches the x-axis, having only one solution, and it is positive 2, 0. Okay, let's take a look at the last one. 2 roots, 2 zeros means that there are 2 times that the parabola touches the x-axis. So let's assume right there, this one, and I don't like this notation, but I'll explain this one in a little bit, is negative 1, 0, and 2, 0. This is the 2 places this parabola touches the x-axis. I know I'm getting boring, but it's also called a root, it's also called a solution, and it's also called the x-intercept. We're not going to go over factoring again, but we have had problems that have 2 solutions. Let's just take a look at the graph. On the graph here, it looks like this and this would be our solutions. I don't like this notation, but remember when we solved them, we had x equals, and that's why that's there. Anyways, the solution would be 1, 2, 3, negative 3, 0, and negative 1, 0. And therefore, it has 2 solutions, 2 roots, 2 x-intercepts, and 2 zeros. As you can tell, they have 0 in the y value. Now, let's talk about this over here. For right now, what we're going to do is give it a best estimate. I'll show you at a later date how we could get an exact value, but for your homework and for the state exam, your best estimate would give you the correct answer. This one would be approximately negative, and I'm going to say 0.25, 0, and this one looks like it is 1, 2.5, 2.5, 0. And and this would help you identify the best answers.